I've always said that wherever you are, there is always something interesting nearby. And look at this. How incredible is this boulder, don't you think? Oh, this isn't CGI. This is real. And just to prove that I haven't video edited this boulder to appear as if it's off the ground, I'll use my walking poles. Have a look at this. So here we go. As you can see, there's no CGI going on here. This rock to me is stunning. Even though this is one of the smaller raised boulders in this area, if we assume that greywacke sandstone weighs approximately 2.6 metric tons per cubic meter, that means this boulder weighs over 12 tons. So how did it end up in this position? Good question. Thank you for asking. Oh, and before we go any further, let's just clarify what I mean when I say the word raised. In this case, I'm talking about something that was once resting on the ground. It was at ground level, but now it's above it. But here's the twist. In this area, it's not that the rocks have moved up. They've stayed exactly where they landed thousands of years ago. You know, they haven't moved. It's the ground around them which has gone down. And yes, I do know that sounds rather odd. So let me explain. I'm here in northern England in an area called the Yorkshire Dales. And more specifically, I'm just north of the village of Ostwick. This area north of Ostwick is known as Norber. And this part of Great Britain has very strong Viking roots. The name Norber comes from the Old Norse words, Nor meaning north and Berg meaning hill. So Norberg became Norber. Quite literally, that means the hill to the north. There's enough history in this area to fill a whole video, but today I want to show you what makes this place really special, and that's the geology. These huge boulders, which are scattered across the hillside, they're known as the Norber erratics. In any area that was once covered by a glacier, you'll often find rocks just like this. Erratics are rocks that were picked up by the moving ice and transported, sometimes over great distances. When the glacier melts, the rocks are left behind and scattered erratically across the hills, and that's why they're called erratics. Normally in geology, older rocks lie underneath younger rocks, but here it's the opposite. Ancient greywacke boulders are sitting on top of carboniferous limestone. This is over 100 million years younger. These erratics, the boulders, are made from Silurian greywacke sandstone, and this formed around 440 million years ago in the ancient Iapetus Ocean, which was located just south of the equator. Greywacke forms when huge amounts of mixed sediments, such as sand and silt and gravel, and even small fragments of rocks, they're rapidly dumped onto the seafloor all at the same time. So often during undersea avalanches or coastal storms, which churns up the sediment. And over time, the layers of this chaotic material build up. With the pressures from the layers above, it compacts it into a dense, gritty, incredibly tough rock. These boulders originally came from the hills and the mountains to the north of here. And during the last ice age, glaciers will have carved through those mountains, tearing off chunks of exposed rocks and carrying them inside the ice. After the glaciers melted about 12,000 years ago, the boulders were just dropped around the hillside. And here's where it gets really interesting. Well, I find it interesting. I'm not sure anybody else will. Greywacke is much more resistant to erosion than the limestone beneath it. So since the glaciers vanished, rainwater has been slowly eroding both the limestone and the greywacke, but at very different rates. Where the boulders landed, they acted like an umbrella, shielding the limestone directly underneath it from the elements. The rest of the exposed limestone hillside, though, it kept wearing away at about 25 millimeters or 1 inch every 1,000 years. And even though the limestone underneath the boulders was protected, the soil around it was still washed away. And if the boulder was in just the right position, it would end up balanced on a small limestone pedestal, which was raised above the ground. And I mean, look at the size of these things. I mean, for this thing just to land in exactly the right position so that it would be supported by this small section of limestone, what are the chances of that? And 12,000 years later, this is the result. Honestly, I'm always impressed when I come to this area. Just enough said. If we go back to the first rock that I showed you, the same process applies. Let's move the camera so you can see it from a different angle. As you can see, when the boulder was dropped by the melting glacier, there was some limestone just in the right place, and over thousands of years the ground around it eroded and the soil beneath it washed away, leaving the boulder resting on those three limestone rocks that you can see there. So it wasn't that the boulder was lifted up, it stayed where it always had been. The land around it subsided, it fell away. Of course, not all of the boulders in this area are raised up. Some are still at ground level. And I'll give you an example. This one here, directly behind me, this is raised up, and that one there is at ground level. And that's because for that one, and many others, there isn't enough limestone close to the surface to support their weight. So as the soil beneath them was eroded, there was nothing to hold them up, and they dropped down at the same speed as the soil was washed away, 25 mil or 1 inch every 1,000 years. So the boulder that you can see at ground level, they have actually moved, but they've moved downwards from where the ice dropped them. And the boulders which are raised up, like this one here, they're still in the same, almost the same position they were 12,000 years ago. But over that time, the ground has gone down. Like I said, there's always something amazing nearby. So you just have to go outside and look for it. You don't need to go to somewhere famous to find something interesting, you know, like the erratics. I'll give you an example. I'm heading down towards where I parked my car. And can you see that cliff behind me? It's southwest of the Norber erratics. It's called Robin Proctor's Scar. Robin Proctor was a local farmer hundreds of years ago, and he was famous for enjoying a drink, or maybe more than one, at the local pub in Ostwick. It wasn't a problem though, because his horse had done the journey so many times, he could find its way home without Mr. Proctor doing anything. But one evening, after perhaps a few too many drinks, Robin mounted the wrong horse, one that didn't know the way back to his farm, and he fell asleep in the saddle. And in the mist and the dark, the horse kept walking, straight over the edge of that cliff. Both the horse and the rider fell to their death. And if we check on the Ordnance Survey map from 1840, we can see that this area, even then, was named Robin Proctor's Scar. The Ordnance Survey surveyors often gathered place names by asking locals about the features they were mapping, and clearly somebody passed on the full gory story, and that's how it got its official name of Robin Proctor's Scar. As I said, there is always something interesting. Thanks for watching.